Why are we choosing Python to do data analysis? Python is the best programming language to learn to code. It's simple, intuitive, and readable. It includes thousands of libraries to do virtually anything from cryptography to IoT. Python is free and open source. That means that there are thousands of eyes, very smart people seeing the internals of the language and the libraries. From Google to Bank of America, major institutions rely on Python every day, which means that it's very hard for it just to go away. Finally, Python has a great open source spirit. The community is amazing, the documentation is exhaustive, and there are a lot of free tutorials around. Check out for conferences in your area. It's very likely that there is a local group of Python developers in your city. We couldn't be talking about data analysis without mentioning R. R is also a great programming language. We prefer Python because it's easier to get started and more general in the libraries and tools it includes. R has a huge library of statistical functions, and if you're in a highly technical discipline, you should check it out. Let's quickly review the data analysis process. The process starts by getting the data. Where is your data coming from? Usually, it's in your own database, but it could also come from file stored in a different format or a web API. Once you've collected the data, you'll need to clean it. If the source of the data is your own database, then it's probably already in shape. If you're using more extreme sources like web scraping, then the process will be more tedious. With your data cleaned, you'll now need to rearrange and reshape the data for better analysis, transforming fields, merging tables, combining data from multiple sources, etc. The objective of this process is to get the data ready for the next step. The process of analysis involves extracting patterns from the data that is now clean and in shape, capturing trends or anomalies. Statistical analysis will be fundamental in this process. Finally, it's time to do something with data analysis. If this was a data science project, we could be ready to implement machine learning models. If we focus strictly on data analysis, we'll probably need to build reports, communicate our results, and support decision making. Let's finish by saying that in real life, this process isn't so linear. We're usually jumping back and forth between the steps, and it looks more like a cycle than a straight line. What is the difference between data analysis and data science? The boundaries between data analysis and data science are not very clear. The main differences are that data scientists usually have more programming and math skills. They can then apply these skills in machine learning and ETL processes. Data analysts, on the other hand, have better communication skills, creating better reports with stronger storytelling abilities. By the way, this radar chart you're seeing right here is available in the notes in case you want to check out the source code. Let's explore the Python and PyData ecosystem, all the tools and libraries that we will be using. The most important libraries that we will be using are Pandas for data analysis and Matplotlib and Seaborn for visualizations. But the ecosystem is large and there are many useful libraries for specific use cases. How do Python data analysts think? If you're coming from a traditional data analysis place using tools like Excel and Tableau, you are probably used to have a constant visual reference of your data. All these tools are point and click. This works great for a small amount of data, but it's less useful when the amount of records grow. It's just impossible for humans to visually reference too much data, and the processing gets incredibly slow. In contrast, when we work with Python, we don't have a constant visual reference of the data we're working with. We know it's there, we know how it looks like, we know the main statistical properties of it, but we're not constantly looking at it. This allows us to work with millions of records incredibly fast. This also means you can move your data analysis processes from one computer to the other and, for example, to the cloud without much overhead. And finally, why would you like to add Python to your data analysis skills? Aside from the advantages of freedom and power, there is another important reason. According to PayScale, data analysts that know Python and SQL are better paid than the ones that don't know how to use programming tools.